my board or what?
Yes.
You're the only one who cannot see it, so I don't know how to help you. As everybody else says they can see it. Okay,
Then
but
if
it's
the
being recorded.
if the
Yeah?
thing is being recorded, then he can just watch it like later on.
Yeah, that's
I'm
what
sure
I
it will
was about
show.
to say. It is
Yeah.
showing.
Okay, thank you.
It's also being recorded. Okay, so here, please let's mute our mics. Sorry. Let's mute our mics. Okay, so there I have -2. This 2 over here, this is what we call the argument. Now, if the argument has an exponent, the laws of logarithm say that the exponent of the argument can come down over there. And then I have -2 log base 2 of 2. Now this log base 2 of 2 is equal to 1. Anything that you take log of that thing to that same base, so the base and the argument are the same, that logarithm is equal to 1. So here I have -2 times 1. This is equal to -2. And that's the answer. This is I have log 8, and then I have a half over there. Okay, to solve this one, I'm going to use the technique of changing the bases of a logarithm. Now, I say technique because that's exactly what it is. So in labs, you have techniques that you use. You must put this, mix it in this way. You must do it at this temperature or something like that. So this is also a technique. Now, if I want to change the base, first I must decide what base I'm going to change to, and then I just follow what I am about to do now. Okay, so I'm going to change the base to 2 because 8 and half, I can write both of those as 2 to the power of something. Now, when you want to change the base, what you do is you form a big fraction over there. Then it's log of that base you have decided to change to in the numerator and in the denominator. Okay, so first I had to decide. People, please mute your mics.
Can you mute yourself, please? We're trying to listen.
Okay, so I said the technique of changing bases is you decide what base you want your new logarithm to have. So I decided to make it 2. So I put log 2 in the numerator and log base 2 in the denominator. Then my argument comes to the numerator, and then the base goes to the denominator. So it's one big fraction, the same log in the numerator and denominator. Argument must go to the numerator, and then the base should go to the denominator. That is how I change the base. So over here, the base of the logarithm was 8. Then now over here, this is now a logarithm of base 2. Then I'll simplify the numerator and the denominator and cancel if anything can cancel. Then in the numerator, I said half. I can rewrite it as 2 to the power of -1. And in the denominator, 8, I can rewrite it as 2 to the power of 3. Then again, the law that says if your argument has an exponent, the exponent can come down and multiply with the log. And same thing over here. Okay, so notice everything I am doing, I am using a law. I'm saying with this law, this is what it says. So do not do anything if you do not know what that there is a law that says you can do that. So the -1 comes down, then I have log base 2 of 2, and then the 3 over here comes down, then I have not -3. And then I have 3, log base 2 of 2. Now we've already established that log base 2 of 2 is equal to 1. Same thing in the denominator, this is equal to 1. So I'll just multiply out my numerator and denominator and simplify as far as possible. So in the numerator I have minus 1 times 1, denominator I have 3 times 1. This is just equal to minus 1 over 3. Now log of 1, 1. Okay, now if you remember, we said that for a logarithm to be defined, your base must be positive and it must not be equal to 1. Okay, so it must be positive number, that means it cannot be 0, and it also must not be equal to 1. Now we see why that is the case. Okay, so here I can say I want to change the base of the logarithm to, let's say, 10. So I'll put log base 10 and log base 10. Log base 10 is what we call the common logarithm, and you'll see sometimes the 10 is omitted, that means it's not written. So when you see something like log 5, that means log base 10 of 5. So here I'll put 1 and I'll put 1. Now there's a law that says log of 1, doesn't matter what the base is equal to 0. Okay, so if I were to rewrite this one here, if I was to rewrite this as an exponent, I'm saying 10 to the power of what gives me 1, and that is 0. So the numerator is equal to 0, the denominator is equal to 0. So I have 0 over 0. This is undefined. And that is why log to the base of 1 is undefined. Okay, so we are not allowed to take log to the base of 1. So that's simple. It's stated as a law, but now you know why it is the case. Let's look at one more of those. We have log base 8 of 4. Now to solve this one, I will change the base to 2 because I cannot rewrite 4 as 8 to the power of something. So the technique again to change the base, I've decided to change to base 2. So I put log base 2 in the numerator, log base 2 in the denominator. My argument goes to the numerator to become an argument. My base goes to the denominator to become an argument. Okay, then I'll simplify the numerator and the denominator and then see if there's anything that can cancel or equal to 1. Now log base 2 of 4, 4 is just equal to 2 to the power of 2, and this is log base 2, and 8 is 2 to the power of 3. Now I have an argument that has an exponent. The law says I must bring the exponent down, and I do that in the numerator as well as in the denominator. So I have 2 log base 2 of 2 over 3 log base 2 of 2. And we've already said that log base 2 of 2, this part is equal to 1 because log of anything to that same base except 1 is equal to 1. So the same thing in the denominator, log base 2 of 2, this is equal to 1. So what I have is 2 times 1 in the numerator over 3 times 1 in the denominator, and this is just equal to 2 over 3. The log base 2 of 81. You see, is it possible to simplify this one? Or can we do anything, make it simpler? Okay, now I know 81, I cannot rewrite it as 2 to the power of anything. But what I can do is rewrite it as 3 to the power of 4. So this is log base 2 and then 3 to the power of 4. Okay, this 4, I can bring it down. This is just 4 log base 2 of 3. So if we're doing this without a calculator, there is nothing else you can do over there. Even if you change the bases to base 3, it won't be any simpler than that. So here is just using the law that if you have an argument that has an exponent, then you can bring the argument, then you can bring the exponent down. So log base e of 7 over log base e of 3. Okay, now I think some of you might already realize that this is just equal to log base 3 of 7. Okay, the reason for that we will see just now. What we can do is, if this is what we have, let us show that this is actually the answer. And then next time when you see questions like this, you will immediately see that, okay, it's like reversing the technique of changing the bases of the logarithm. Okay, so if I have this log base e of 7 over log base e of 3, what I can do is change the base of the logarithm. I'm going to change the base of the numerator to 3 and the denominator to 3 as well. So log base 7, this one over here, when I change the base, I said I write one big fraction and then I write the new log. This is log base 3, in the denominator as well, log base 3, and then 7, and then 7. So this is the numerator. This part over here is my numerator. Then this is dividing by log base e of 3. So I want to change the base. I follow the same technique. I say this is log base 3, log base 3, and then the argument 3 goes to the numerator, and then the base e, sorry, this was supposed to be e. Okay, so from there, this e over there, and then this is e. Then I have two fractions dividing. The division should change to multiplication, and then I write the reciprocal of my second fraction. So this is log base 3 of 7 over log base 3 of e multiplied by log base 3 of e. And then here, log base 3 of 3, if you remember, anything that you take log off to that same base, this is just equal to 1. So I have 1 over there. And then these two, when we're multiplying, because they're the same, one is in the denominator, the other is in the numerator, they cancel each other out. So I am left with log 3 of 7 over 1, which is just log base 3 of 7. Okay, so what I started with was this over here. This log base e, another way of writing it is ln. So ln of 7 divided by ln of 8. This is just equal to log base 3 of 7. And here, if this is what you were given, and then I say change the base to log e, you would write one big fraction, put log e in the numerator, log e in the denominator. The 7 becomes goes to the numerator, and the 3 goes there. So the technique of changing bases works in both ways. So if I give you anything like this, log x over log a y, This you should know right away. I can rewrite it as log. This becomes the base, and then this is the argument. I can rewrite it like that as long as I'm dividing by logarithms that have the same base. Now we look at some logarithmic equations. But before that, let's look at question 5. This is a 10. So we are asked to evaluate this as far as possible without a calculator. Here, this is the common logarithm because the base is 10, so I don't even need to write the 10. I can always rewrite it as log 10 minus log 12. Then, because I'm subtracting, the laws of logarithms said if you are subtracting logarithms that have the same base, then what you can do is combine them. Yes? Yes.
Is it supposed to be log 10 or log 15 minus log 12?
Log 15, thank you. Okay, so the law says that if you're subtracting logarithms that have the same base, then what you do is you can write them with a single logarithm and you just divide the first argument by the second one. So this is log 15 divided by 12, and then 15 divided by 12, you write it in its simplest form. 3 is a common factor, so it's 5 and 4. So this is log 5 over 4. And that's as far as you can go without a calculator. In the next one, we have log 5, the fourth root of 25 minus log 25 of 125. Okay, now here you cannot just combine these logarithms. You can see over here the base is 5 and over there the base is 25. So you cannot just combine them. The laws apply to logarithms that have the same base. So what you can do is change one of the bases of the logarithm to the other one, and then you can see if you can apply the laws. But as they are, I cannot just say this, the fourth root of 25 divided by 125. That would be wrong. So what I do, okay, okay, so this first one, I have log the base of 5. Okay, and then 25, I can rewrite it as 5 to the power of 2. So it'll be 5 to the power of 2 and then to the power of 1 over 4. So it's to the power of 1 over 4 because the fourth root means to the power of 1 over 4. And then the second logarithm, I'm going to convert it to a base of 5. Mainly because 25 and 125 can be written as log to as 5 to the power of something. So the technique again, one big fraction, the same log 5 in the numerator as in the denominator, the argument 125 to the numerator, the base goes to the bottom over there. Okay, so we go back to this one. I have 5 to the power of 2 to the power of 1 over 4. I should multiply the exponents. So I have log base 5, and then I have 5 to the power of a half. 2 times a quarter is equal to a half. And then this 125 over here, I can rewrite it as 5 to the power of 3. So I have log 5 to the power of 3. And then the 25 in the denominator, I'll rewrite it as 5 to the power of 2. So this is log base 5 of 5 to the power of 2. Okay, I have an argument that has an exponent. The law says I can bring the exponent down so that it multiplies. So I have half log base 5 of 5, and then the same thing over here. This exponent of the argument can come down. This exponent of the argument should also come down. So I have minus 3 in the numerator, log 5 base 5 over 2 log base 5 of 5. Okay, now this part, log base 5 of 5, we say this is equal to 1. This is equal to 1. And that is equal to 1. Now the reason all these are equal to 1 is because when you take log of anything to that same base, the answer is always equal to 1. So I have half times 1 minus 3 times 1 over 2 times 1. Okay, half times 1 is just half, and then this fraction is 3 over 2. So half minus 3 over 2, this is equal to negative 1. Base 7, 1 over 49 minus 2 log 2 square root of 2. Okay, to solve this one, again, you'll see that the bases are not the same, so you might have to do some simplification before you can combine the bases. And another thing, you can see that this base, this logarithm over here, has a coefficient of 2. Now you cannot combine, even if the bases were the same. Let's say over here the base was 2. I could not combine them if the coefficient over there is not equal to 1. So what I will always have to do before I combine logarithms is take the coefficient back over there. All right, so the first one, 49, I know I can rewrite that as 49 to the power of minus 1. So this is log base 7. And then I have 49 to the power of minus 1, and then minus log base 2, and then this 2, when it goes up there, it becomes the square root of 2 squared. I'll just write that.
Miss,
This is the square root. Yes.
I think you skipped the previous one, the one of log 27 base 9.
Okay, I'll do that one after.
Okay, Miss.
Okay, so I continue. Now 49, I can rewrite it as 7 to the power of 2. So I have log 7, and then I have 7 to the power of 2 to the power of minus 1, and then minus log base 2 of 2, because the square root of 2 squared is equal to the square root of 4, which is equal to 2. And this is equal to 1. Log base 2 of 2 is equal to 1. Right, so here I have 7 to the power of 2 to the power of minus 1. I can multiply those two logarithms. So this is log base 7, 7 to the power of minus 2, and then minus 1. Okay, because log base 2 of 2 is equal to 1. Then I have an exponent of the argument. The exponent will come down, so I have minus 2 log base 7 of 7 minus 1. Then again, log of anything to that same base, this is just equal to 1. So I have minus 2 times 1 minus 1. This should be equal to minus 3. Then the previous one, this one is C. Log 927 plus log 525. Okay, now this one over here, with the first logarithm, I see that 27, I cannot rewrite it as 9 to the power of anything. The best I can do is write 27 as 3 to the power of 3, but 9 can also be written as 3 to the power of 2. So I think I will have to change the base of the logarithm. So the technique again, I have one big fraction. I've decided to change to log base 3, so I put that in the numerator and in the denominator. Then my argument goes to the numerator, my base goes to the denominator. That is the technique. Okay, then for the second one, 25, I can rewrite it as 5 to the power of 2, so I don't need to change the base for that one. So this is just log base 5, 5 to the power of 2. Then I simplify. 27, I said I can write it as 3 to the power of 3, and 9, I can write it as 3 to the power of 2. So I have log base 3, 3 to the power of 3, over log base 3, 3 to the power of 2, and then over here, my argument has an exponent, so I can always bring the exponent down, and then I will have 2 log base 5 of 5. So that's what I'm also going to do over here. The 3 will go down, the 2 will go down. Then when the 3 goes down, I have 3 log base 3 of 3 over 2 log base 3 of 3, and then this is 2 times 1. So log base 5 of 5, this is equal to 1, because anything to that same base, log of anything to that same base is equal to 1. Then that is the same reason why log base 3 of 3 is 1 in the numerator and in the denominator. So I have 3 times 1, which is 3, over 2 times 1, which is 2, and then I add 2 times 1, which is 2. So I have 3 over 2 plus 2, that's 1.5 plus 2, this is 3.5, and this is just 7 over 2. And then for E is a little bit longer, so I might have to split the way I write it. So I have log base 3, 81 to the power of minus 1, plus log base 6, 1 over 36, minus log base 3, 9 to the power of minus a half, and then I add log base 201 of 201. Okay, so I'm sure right away you can tell that this is equal to 1. Okay, the log base 201 of 201 is equal to 1, right? And then the others, I can simplify them. For the first one here, 81, I can write it as 3 to the power of 4. So I have log base 3, 3 to the power of 4 to the power of minus 1. And then for the second one, 1 over 36, that is 36 to the power of minus 1. And then 36 is also 6 to the power of 2. So I have log base 6, and then I have 6 to the power of 2, then to the power of minus 1. So 6 to the power of 2 is 36, and then when I raise it to the power of minus 1, then it becomes minus 1 over 36. And then the second one, the third one, let me just make space there. Okay, then the third one, I have log base 3, and then 9 to the power of minus half. 9 is 3 to the power of 2, and then to the power of minus half, and then this one over here that I worked it out, so it's plus 1. Okay, then I will just multiply my exponents and then bring them down. So this, for the first one over there, this is log base 3, 3 to the power of minus 4. And then the second one, this is log base 6, 6 to the power of minus 2. So I'm just multiplying the exponents. Yes.
I kind of lost you there. Where did you get the plus 1? I think I got behind the
from here.
Yes.
From here. Okay.
Yes, miss.
That's also why I'm recording this. Then you can watch and see where I got the 1, because I did say that log of anything to that same base is equal to 1. So you can see log of 201 to the base of 201 is no longer written, and instead I replaced it with 1.
No, fine. Thank you, miss. I got it.
Okay, awesome. Then the third one, this minus, and then over here 2 times minus half, that is minus 1. So maybe let me put the minus here. So this is minus log base 3, and then I have 3 to the power of minus 1. So the 2 times the minus half, and then this 1 over there. Okay, then I have single exponents for my arguments. All of those will just come down. So I have minus 4 log base 3 of 3 minus 2. So it's plus, this plus, and then when the minus comes down, then it'll become negative. So that's why I'm not writing plus minus, it's just minus. Then this is log base 6 of 6, and then again when this minus comes down, multiplies with this minus over here, I will get positive. So this is positive log base 3 of 3, and then this one just as it is, I write it there. Okay, so it seems like this is much longer, but it's actually not. I'm just trying to show as many steps as I can. So some of these you can do them in 2 or 3 steps. I just want to do as many steps as we can so we all understand. Okay, now this log base 3 of 3, this is equal to 1. So I have minus 4 times 1, which is just minus 4. And also this one, log base 6 of 6 is equal to 1. So I have minus 2 times 1, which is minus 2. Log of 3 to base 3 is equal to 1. So I have plus 1 and then plus 1. So negative 4 minus 2 is negative 6. Negative 6 plus 1 is negative 5. Negative 5 plus 1 is negative 4. And that is our final answer. Okay, so it seems a bit long, but the more practice you have with logarithms, some of these you can do them in just a few steps. Now we're looking at some logarithmic equations. So again, for the examples, I do not really want to do them because I want you guys to take it as an exercise. You try it on your own, and then the working is there for you so you can see if what you did is correct or not. So look at the exercise. The first one, we have to solve the following logarithmic equation. The first one says log base A of x plus log base a of 4 minus log base a of 5. This is equal to log base a of 12. Okay, so I want to solve
Ma'am,
this. That means, yes.
can I quickly take you back
How
just to
far
the
back are
equation
you
that
taking me? Just the
it's
previous one?
the log, yes,
Yeah.
where there's log 6, which 6 is a base and a 6 is a
This
argumentative.
one
Can
here?
you not simplify it?
You mean this one here? Or which one?
Mm,
Can you see my pointer over here?
no. Go back again. Up. Yes, here. Where,
This
yes,
one?
where there is
Mm.
log 6, 1
Mm-hmm.
over 36. Can you not simplify the log 6 into 3 to the power of 2?
No, you cannot do that because 3 to the power of 2 is 9. So you cannot change that one. Okay? 3 to the power of 2 is 9.
And 2 to the power of 3?
2 to the power of 3 is 8. Okay. All right. So here when we're asked to solve this, what we're looking for is actually x, because you will see that it doesn't matter what your base is. If I put 5 as a, I will still get the same value of x if I solve for x correctly. So when I give you a question like this to solve, I'm not looking for the value of a. What I'm looking for is the value of x, because a doesn't actually matter. It'll work for any base a for which the logarithm is defined. Okay, so on the left hand side, my left hand side is this one over here, this part. Now the bases are all the same. It's all base A. The first two are adding and the last one is subtracting. Now let me just split this up because this is very important. The order that you do this in can affect your answer. This is log S plus log A4 minus log A5. Okay, now you cannot add these two together or combine them, and then okay, maybe with this one it's fine. If I was if I had more terms, I cannot subtract two of them, get an answer, and then that answer subtracted from another term. Maybe that's what I mean to say. But with this one, I guess it's fine. But what we do is, let's go from left to right. We'll see this when we have more equations, more logs. Okay, the bases are the same. So what you should do is just use the law that says if you have a sum where the logarithms have the same base, you can combine the arguments by multiplying them. So here I just multiply. This is log base A of x times 4. X times 4 is just equal to 4x. And then I subtract log base A of 5. Okay, so I'm only working on the left hand side just because of the space I have here. Otherwise, I would write the equal to and that other thing over there. All right, now here I have two logarithms. This is my first one. This is my second one. The first one I got by combining these two logarithms. Okay, so I now combine it with the third one. The bases are the same. That is the key. The bases are not the same. You cannot combine the logarithms. So the bases are the same, so I'm free to proceed. Then I'm subtracting. Then I can divide the two arguments. So this is log, the base stays the same, it doesn't change. This is 4x over 5. This was my left-hand side. Now I'm going to write the equation. On the other side, I had log base a of 12. So I've simplified the
Ma'am,
left-hand side. I didn't, yes,
ma'am, why is it 4x
it's x times 4.
at log A?
This, because
Why is it?
I'm adding over here.
Oh,
So I should multiply the arguments.
okay, ma'am. Okay.
Okay, and this is equal to log a of 12. Now this we solve by comparison. On the left hand side, I have log base a of this, and on the right hand side I have log base a of 12. I'm taking the same log on both sides. It means that my arguments are equal. Or what I can do is raise both of them to the power of a. I think you've seen the law that says if I have a to the power of log base a of b, this is equal to b. So I have a base, I have an exponent whose exponent is a logarithm, okay? And the base of this exponent or exponential equation is the same as the base of the logarithm. It's like they cancel each other in a way, and I'm left with b. So you can prove that one. So either I will take both of them to the power as a power of a, or I'm just canceling them. I say that I'm taking the same log on both sides. The answers are equal, so it means 4x over 5 is equal to 12. Just like when we used to do something like this, 2 to the power of x is equal to 2 to the power of 3. Then we say that our bases are the same, then it means x is equal to 3. So something like that. Then from here, I solve for x. I will have 4x. So this is side note. So I have 4x is equal to 12 times 5. This is 60. Somebody speaking with their mic on. And then I divide by 4 on both sides. Divide by 4. Then I get x is equal to 15. Okay, I think we have time for just one more.
Ma'am,
Yes,
ma'am,
yes.
how did you come to 2 to the power x there?
No, this was an example. This is not part of
Oh,
the
okay.
question. That's why I put it in a box, okay? I was explaining that when we had equations like this, 2 to the power of x is equal to 2 to the power of 3, I would say that the bases are the same. So that means x is equal to 3. So it was just an example. It's not part of the solution.
Miss,
Yes,
Miss,
yes.
Miss,
Um,
how did you get 60? I got lost because it was equal to 12. How did you get the 60?
Yeah, how will you solve for x here? What will you do?
Can I explain?
really,
How
You
will
would
you
make
solve
say
for
for
x?
X the subject of
You make x the
60 is
subject of the
most,
formula exactly. 12 times
yeah,
5.
Yeah.
Multiply by 12 on both sides, by 5 on both sides, you get 60. And then you divide by 4.
Miss, Miss,
Oh,
exactly.
I did
Just
not.
scroll up a
Thank
bit.
you.
What's your question? I can barely
Just
scroll.
Miss,
scroll up.
Up to where?
Uh, from that question, Miss.
Which question? I cannot see your
Yeah,
finger pointing
exactly.
at the question. Mm.
Here, Miss. It's where I want. I just want to copy something.
You just want to do what?
I just want to confirm the 4 and the 5 here. I didn't get the. Okay, it's fine. I'm done with it.
Oh, okay. All right. Again, this is
so
being
ma'am,
recorded. So if you miss anything, you can watch the recording and see what I said on that. Yes.
can't you also take there where we have log ax plus log 4, log a4 minus log a5. Can't you take the log base a of 4 minus log a of 5 on the other side, and then obviously change the signs, and then just work with the left hand side with the x, and then you go use the numbers on the right hand side.
Ma'am is muted. Ma'am, you are muted.
This is not the only way to solve it. Can you hear me now? Hello?
Yes, ma'am, we can hear you now.
Oh, okay. Right. So this is not the only way to solve it, okay? It is possible to use other laws to solve it. So it's not like that is the only way to do it. As long as you are using the laws that are on your list, then you are doing the right thing. Okay, I think now we don't even have time to do one more question.
Ma'am?
Yes. Yeah.
I want to ask the part whereby you cancel the log A with another A. Why did you cancel with an A?
I believe that's one of the laws that you have. Let me scroll up on my laws and see if I have it here.
We have another coming up now.
Yes, it's law letter G. Law G in your notes. It's one of the laws. Yeah.
Okay.
Yeah.
Yes, we have another class that's coming up now.
Me. Or you have another class. If you have another class, please, you must go to your other class. Okay? Like I said, I'm recording this, so I will post it and send it to you if you miss anything. So again, just to remind you guys, please, WhatsApp is not for official stuff. So if you have any problems, rather send me an email. And e-learning, please try and do it after hours. After hours is from 9 o'clock onwards. Okay? So it's from 9 o'clock onwards because yeah, or the weekend. The test is open until Sunday afternoon, so you can still do it in the weekend. The tutorial test, yes, the test. The tutorial test. Yes.
Okay, ma'am.
Okay. So please, after hours, or at the weekend, please.
Okay.
Okay. If there are no more questions, then for tomorrow's class, I have a doctor's appointment, so I might have post a recording, or can we have the class earlier, like at 8 o'clock?
8 o'clock.
Let's see.
What do you have at 8? You have biology from 7:30 to 8:30.
We can't have it at 8 o'clock. We have another class by then.
What time is your other class?
Miss, you can have at 8:30 to 9:30.
But we can most also have it at 7:30, isn't it, guys?
7:30 we have biology.
We have biology. We have class till 12:30, ma'am. We have class till 12:30.
Okay.
Then we can actually have from 8:30 till 9:30 because we do not have chemistry classes, online classes for the meantime. So where we have chemistry, we can have a class.
So 8:30.
Ma'am can just do a recording. I think that one will solve every problem.
I can also do a recording because I will log on just like this meeting, but I'll be the only one there, and then I will record everything I am doing. If we cannot find the time, then I will post it. No, just like we're having a meeting now, except I'll be the only person there. I'll be recording it. Then I will post it.
Okay,
Sorry?
ma'am.
If you want to join, I can send you a link what time I'm recording it, and then you can join if you want to. If you cannot, that's also fine. Okay.
Okay.
Yeah.
Miss, you are the best.
I know. Okay, I'll see you guys Bye.
Miss,
Yes.
Miss, are you posting the videos on e-learning?
Yes. Everything I post, I will post here on e-learning and on YouTube.
Okay, Miss.
Okay, Miss.
Thanks, Satan.
Thank you.
Bye.
Bye.
On the 7th,
Bye, Miss.